Science fiction becomes reality with the help of what's being dubbed a bionic eye. Mika Tero, a Finnish man, was able to read his name for the very first time since an inherited disease robbed him of his sight more than a decade ago. The German-designed implant is being hailed as a breakthrough that could be the cure in many cases of blindness. Mika was among 3 patients who took part in a study just published in Proceedings of the Royal Society. Within days of having the groundbreaking retina implants, they were all able to recognise and locate objects, prompting applause from the German inventors. Take a listen.
I see a table right here.
Yeah.
I mean, plate.
Plate, yeah.
And then there's a knife here.
Yeah.
And this one looks different on the right, so I would say it's a spoon.
Mm-hmm.
And then there's a mug here.
Well, what a moment. British researchers will carry out clinical trials of the implant next year. Dr. Robert McLaren from Oxford University will co-lead the UK study. I spoke to him earlier and began by asking him just how many people this technology could actually help.
Well, the technology is really applicable for people who have lost sight due to loss of the light-sensitive cells known as photoreceptors, which line the retina at the back of the eye. And the common disease that causes that is retinitis pigmentosa, and this affects about 1 in 3,000 people in the developed world. But the clinical trial that we're involved with will involve certainly initially implanting patients who are completely blind, and that would be a smaller percentage of the total number.
So if you can, give us a sense, or give sighted people a sense of what these people can see or what they can sense after a successful operation like this.
Well, these patients have had complete blindness for many years, and in one case, the patient who's shown in the video, his sight loss had been more than 10 years. And what they describe is seeing letters or shapes as if they were looking at them on the floor of a swimming pool, looking through the surface. So in other words, seeing a sort of rippling effect of the letters as they read them. Because we have to bear in mind, of course, that the vision that they see is not normal by any means. Their brain has to learn how to reinterpret the images that come from the electronic chip.
So how, in layman's terms, does it actually work?
Well, the chip is light sensitive and it stimulates the retina through electrodes which are placed on the light sensitive pixels. There are approximately 1,500 pixels, and that gives you an idea of the resolution of the image. The pixels then stimulate the retina, which is overlying the chip, and the retina, which has cells in it which are still there but non-functional, is then able to send those signals back via the optic nerve to the brain. And we really didn't know if the retina was capable of doing this after a long period of degeneration. We always thought that that would be the case, but we never really knew for sure. And what's really good about this study is the proof of the principle that if you do put an electronic device in the retina, even though there are no light-sensitive cells there, the retina and the optic nerve are still intact and the patients can see again.
And that technology will only improve, won't it? So the images will become better over time.
Yes, I mean, absolutely. I mean, there are a lot of questions which we still need to answer, and this is one of the reasons why we're doing the clinical trial. We don't, for instance, yet know what the maximum size of implant could be. We don't know how long the implant will last. We don't know how many diodes or how many pixels the implant should have. The only way we can find this information out is by doing this sort of clinical trial. And we can do this sort of clinical trial because of the fantastic results that have come out of the study that's just been published today.
And a really big breakthrough would, of course, be some way of tackling the blindness that people get as they get older. Would this technology help with that?
Well, if you're referring to age-related macular degeneration, you know, this is a condition which affects 300,000 people in the UK and similar high prevalence in other countries in the developed world, then the mechanism is pretty much the same in that these patients lose the light-sensitive cells, but the rest of the optic nerve is intact. So, you know, in future, if the technology improves, it may well be applicable for patients who have age-related macular degeneration. Absolutely, yes.
So we could look back on this as a truly revolutionary moment in your area of medicine, because it could, in theory, be the beginning of a cure to blindness.
Yes, I mean, we have to bear in mind that this is for people who have lost the light-sensitive cells, the photoreceptors, but it wouldn't be applicable to those who have lost their eye or who perhaps have lost the optic nerve or some other problem between the eye and the brain. But, you know, nevertheless, loss of photoreceptors is a common cause of blindness in a lot of diseases that we treat, which are currently untreatable. And this technology has shown that there may be possibility of treatments which could help patients in future. Absolutely.
Unbelievable, isn't it? Well, the bionic body is certainly starting to take shape. Let's take a look at some of the other advances that have been made around the world. Australian scientists are credited with the bionic ear, otherwise known as a cochlear implant. It allows people born deaf to hear clearly. In July, scientists in New Zealand unveiled robotic legs. Paraplegic Hayden Allen demonstrated how they helped him walk again. Prosthetic limbs are also getting more and more advanced. Scottish researchers are behind the bionic hand, complete with moving fingers. And a bionic heart even is being made in France. The advanced twin pump device has already worked on a cow, and tests on humans are imminent.